All right, PCA students, we're going to get into really the first part of trigonometry for us this year, and we start by taking a look at what we call the unit circle. And the unit circle is something that you guys will get to know and love over the course of really the next 3 chapters of trigonometry. And it starts with basic definitions of trig functions that you guys have seen before. So sine, or sine, as it says there, is the opposite over the hypotenuse. Cosine, COS for short, is the adjacent over the hypotenuse. Tangent, or tan for short, is the opposite over adjacent. And that was SOHCAHTOA. We're speeding through this because that is something that you learned in geometry, and what happens above this unit circle below here. What happens up here, you either just worked on some in-class examples or watched a little video that was taken from a geometry class to reintroduce you to some of these trig functions. Okay? From that video or from your work in class, there are some special sine and cosine values. We call them special because they're derived from special right triangles. Okay? So we need to know 30-degree angles, 45-degree angles, and 60-degree angles. And if you have a good understanding of where these sine and cosine values come from, this unit circle and the ability to evaluate trig functions of different degree measures is going to come very easily to you. Okay? So sine of 30 we learned was 1/2 always. Okay? And then cosine of 30 was √3/2. Both sine and cosine of 45-degree angles was √2/2. And the sine of 60 and the cosine of 60 were really just the reverse of these two here. We can talk even further about that in class time, why that's the case. Should make a lot of sense based on right triangle trigonometry and what sine and cosine represent. Okay? Sine of 30 and cosine of 60 come from the same triangle, just looking at the same two lengths from a different angle. Okay? All right, so we understand that. We've done some work on that prior to even watching that video. Where are these going to come into play a little bit? Well, we're going to start slow and really talk to you about what the unit circle is. This is a unit circle without the trig values, but with all of the degrees and something new that you've never learned before, what we call radians. Okay, so a radian, okay, the formal definition of what a radian is, we're not going to go through during this remote learning environment. We would do something actually kind of cool if we were in class to introduce you to a radian. If you're really curious about the definition of a radian, you can Google it, come up with a pretty simple definition of it. Right now, what you need to understand for the purpose of our trig here is that radians, okay, are another unit of measure for angles. Whereas you guys are used to degrees, 30 degrees, 45 degrees, 60 degrees is the opening from this horizontal axis here. This is a 30-degree angle. But it's also a pi/6 radian angle. Okay? Just like you could measure the length of something in both feet and centimeters and the American measurement system or the metric system, similar type of thing. We can have an angle measure in degrees or in radians, just a different unit. Okay. We start, so the unit circle here. Okay, it's called a unit circle because the radius of the circle is 1 unit. Okay, it really standardizes some of the trig functions that we're going to talk about. But most importantly, it starts on the rightward, if you will, the positive x-axis. That is the 0-degree mark. Then everything goes from there. How many degrees does a circle have? It has 360. So when you start traveling this direction, we get to 30 degrees, 45, 60, 90. That makes a lot of sense, right? A 90-degree angle all the way to 180. Then one full rotation around the unit circle is 360 degrees. Okay. What else should we talk about here with the unit circle? We can technically go in a positive angle measure or a negative angle measure. 30 degrees is here. From 0, we would go this way to find positive angle measures. From 0, we'd go this way to find negative angle measures. So where this angle here is 330 degrees, it actually also would be negative 30 degrees. Okay? These are things we'll get more in depth with in part 2 of the video. Okay? Now, there are quadrants here. Okay? This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. You can think of this just like a standard XY coordinate plane, except we're drawing angle measures within that. Okay? All right. Now, evaluating trig functions in the first quadrant, as you can see, the angles, the special angles in the first quadrant of the unit circle are the ones that we referenced in the video and the ones that we referenced up here. Okay? Now, on the unit circle, we also give you the radian measure for each of these. We'll talk about how we can convert that. We'll talk about your ability to understand where these angle measures, these radian measures come from as we go along. Okay. So the trig functions in the first quadrant, well, those are just our, again, I'm just going to kind of draw an arrow here. I'm going to circle this. These are evaluating our trig functions in the first quadrant. Okay. If I asked you for sine of 30 degrees, with nothing written here, you would know that that's 1/2. Okay. So let's go to a little picture of a little bit deeper look into the first quadrant. So we turn the page. Okay. Here is just the first quadrant with also the cosine and sine values at each one of these 8 angles. Here we have them written in radians. Okay, 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. And 60 degrees is pi over 3 radians. We'll talk about how to convert back and forth, or the conversion used, just like when you're doing some unit of length. I know I'm making that comparison a lot. There's a conversion. Okay. These here, these points on the unit circle, these are called the terminal points, or terminal point. Okay. So when we ask you for the coordinates of the terminal point of a certain angle, the terminal point of pi over 6 would be the point √3 over 2, comma 1/2. Okay. So the terminal point, important properties of the unit circle, is the coordinates on the circle at a specific angle measure. And yes, just like a coordinate plane, it would be the x comma the y. But more importantly here, the horizontal part of the unit circle, okay, represents cosine. And the vertical part of the unit circle represents sine. Why is that? Well, let's just draw one, what we call a reference triangle. We'll get more into reference triangle in the second part of the video. And we're going to call this our theta, or our pi over 6, or our 30-degree angle here. Okay. If this is the angle that we're looking at, well, the horizontal part, remember, because the radius of the unit circle will always be 1, that's what a unit circle is. Okay. Then the adjacent to this angle is the x. The opposite of this angle is the y. If you want some reasoning behind y, the sine value is represented by the y-coordinate because that's the opposite. And if it's over a hypotenuse of 1, this really doesn't matter. Why is the cosine representing the x-coordinate of this point? Because the x is the adjacent if we were to create this right triangle. And think back to what we learned in geometry and that kind of pre-video for us. Okay. Most important part of what we learned from this video really is how to deal with the angles in degrees and radians and also an introduction just to this first quadrant in the unit circle. As you can see, a radius of 1 on the x-axis at 0 degrees or radians. We have a point 1 comma 0, which means cosine is 1 and sine is 0 at 0 degrees. And then on the y-axis here, at 90 degrees or pi over 2 radians, cosine is 0, sine is 1. We're not going right and left, we're going straight up. So the x would be 0, straight up 1 unit gives us a y of 1. Okay? Coterminal angles are defined as angles with different degrees, measures, I guess, or radians, that have the same terminal point. Now, how could that be? I'll show you. 0 degrees, 90 degrees, 180, 270, and again 360 right here. So let's talk about this. All right. You will notice and you will see that we can go around this unit circle as many times as we want. Okay. If I said, where is the 30-degree angle? Here's 0, positive 30. This would be our 30-degree angle. Okay. It has a terminal point of root 3 over 2 comma 1/2. If you don't believe me, just check your unit circle above. Okay? That's because cosine of 30 is root 3 over 2, sine of 30 is 1/2. All straight back to our special right triangles. Okay? Now, what if I said, where is 390 degrees? 390 degrees is past 360, and that's okay. We can evaluate 390 degrees. We just need to figure out kind of how, quote-unquote, far we're traveling around the circle, how many times. So if I start at 0 and I want to go 390 degrees, well, I go 90, I go 180, I go 270, I go 360. Now I need to keep going another 30 degrees because 360 plus 30 is 390. So this point is also 390 degrees. Go another time around the unit circle. This point is also 750 degrees, and so on and so forth. Okay? These three angles would be classified as coterminal angles. They are different degree measures, but they end up at the exact same terminal point around the unit circle. We'll do some more work with coterminal angles. Okay? You can even go in a negative direction. This would also be negative 330 degrees. If I go in a negative direction, I'm going this way 90, this way 180, this way 270. Another 60 gets me to negative 330 degrees. Last but not least, converting radians to degrees and vice versa. So to go from degrees to radians, we multiply by pi over 180. To go from radians to degrees, we multiply by 180 over pi. And I will prove to you that the linkage between the degrees and radians. If we had 30 degrees, which according to our unit circle is pi over 6, let's do our conversion of multiplying by pi over 180. We would get 1 pi over 6. These would cancel to a 1 and a 6. 30 degrees is pi over 6 radians. You can even do another one. If we had pi over 4 radians and we wanted to convert to degrees, we'd multiply by 180 over pi. That would end up equaling 45 degrees. Okay, so we went fairly quickly. A lot of basic stuff here. Okay, but something probably pretty foreign that you're not quite used to, but it all stems from, I don't want us to forget this. I know we have, degrees and radians that it's going to take a little time to get our minds around here. But in terms of the values, the sine and cosine values of all of these degree measures, all of these radian measures, including when we go to quadrants 2, 3, and 4, your knowledge of those special right triangles, the 30, 60, 90, and the 45, 45, 90, are going to be what you come back to all the time, which is why we opened with either those in-class examples or that kind of pre-unit circle video. Okay?